Thank you. So I would like to thank the CCP4 core team for inviting me to give a short overview of CCP4 Cloud and how we use it at Newcastle University. So I'm the X-ray facilities manager for macromolecules in Newcastle University since 2009. I'm also one of the Diamond user representative with Dave Briggs as well, who's from the Crick Institute in London. So part of my job is to collect synchrotron data, as well as do user training in equipment and sample handling, as well as software and crystallography. I do a fair bit of IT, maintaining the hardware and software installation and updates. And I've been quite lucky to work on a wide range of resolution from 0.79 to 3.5 angstrom data. And since I've been in Newcastle, I deposited 73 models. So what is CCP4 Cloud? So first, what is CCP4? It's a collaborative computing project, and basically it's a collection of software done by people to help processing X-ray macromolecule crystallography data. So it starts after data collection with processing to help solve the phase problem by molecular replacement or experimental phasing, as well as model building and refinement, and finally validation. So CCP4 Cloud, in short, is a web interface. Of course, it's much more behind the scene. And it can be accessed from anywhere in the world, irrelevant of the operating system and the device. It has also a tree view, which is unique to the X-ray software. And it's not CCP4 Online if you have used CCP4 Online previously. So how do you get CCP4 Cloud? You have to have CCP4 installed, and you may see this icon here, CCP4 Cloud Desktop. This is the standalone version, and I will not speak about it today. But rather, I would speak about CCP4 Cloud Remote. So this needs to be configured, but basically it will connect to a server and run the calculation and keep the data on the server. And if you start CCP4 Cloud this way, the CUD task is available. Direct access is possible as well from a web browser, but then you will not have the CUD task. And I just put an example here as well on Linux command line, how to start the remote. So here is the login we have for CCP4 Cloud in Newcastle. And if you don't know what to do, you have a lot of hyperlinks you can see in blue. For example, if you click on the roadmap, you will get basically what CCP4 Cloud does. I know it's too small to read, and I will not go in details of everything, but today I will illustrate how I use the molecular replacement. So you can see here that you have, for example, a little camera, and that will link to a YouTube video explaining how to use this task. You have as well those little eye icon, and that's for the documentation, which is pretty nice. And as well, the documentation is hyperlink, so you can go explore in more details. So here is how I would use CCP4 Cloud for a textbook molecular replacement project. Those data were collected the second week of December, and it's a collaboration with John Marswright at the School of Natural and Environmental Sciences in Newcastle and Dom Campopiano at the School of Chemistry in University of Edinburgh. I've imported the sequence, and now I'm importing the data, which in case are an MTZ file. So you have few icons around CCP4 Cloud, and don't hesitate to leave your mouse on them, and you will get a little description of what they do. So the data should be uploaded now. And next, I like to run pointless, aimless, and to decide about my resolution. I've speed up the video 2 times, and as well I skipped like here in interest of time. It takes slightly longer, but it's not too bad. So in this case, my signal to noise it may be a bit low to my liking, 0.8, as well as the CC half. So I will follow the guidelines and cut the data at 2 angstrom. For clarity and housekeeping, I just delete the previous task. And so now I can go on, and first I would like to know how many copies of my molecule I need to find. So I run the asymmetric unit content, and I have 2. I like to run the automated pipelines for molecular replacement, which are MORDA, Basle, and Mr. Bump. But I would like to try as well myself to do a molecular replacement. I can't do it because I do not have a search model. So I use PDB-E. And in advanced search, I can search for some good search model using the sequence of my target. And the second entry here seems to be at 2 angstrom in the title. It's only 34% identity. Okay, 3 QVT. So I can now import directly from the PDB to the cloud. And then I can prepare the model for molecular replacement. You can prepare it in different ways. I tend to use MolRep. And here are the results. So I've used both phaser and MolRep. Both of them worked. And I tend to run a round of RefMac for refinement, brought down a bit the R factors. And I really like to use CCP4 build, which will automatically improve your model based on your sequence and the data. It takes a little while to run, few hours, but really in only very few steps, I get a fairly good model if I'm judging by the R factors of 19 and 24. So I would like here to illustrate a little bit more complicated molecular replacement project. Again, collaboration with John, and as well as Annie Paloyan in the Scientific and Production Center in Armenia. So it's a homodimer we have to search for in the data, but each monomer has 2 domains with a flexible linker. And so we had trouble finding a solution because we didn't know the relative placement of each domain with each other. So we tried every possible combination, D1, D2, and molecule A and molecule B. And we didn't go really far, getting very high factors, high R factors. So it didn't seem to work. So then we tried the most common space group, P2121, but that didn't work either. Yet I also ran MORDA again, and basically that's what worked. And that's it. With MORDA, we found a solution. So here, the point I'm trying to illustrate using CCP4 Cloud, but that is true for any other interface, is try everything. You never know what will work. And at the end, if it solves your data, you will be really happy. So here is a illustration of some function. So you can display a PDB file in text format on the CCP4 Cloud. You can also look at your data with View HKL. And you can use ugly mole. So this is completely online based. So you can have a quick look at the model, the density, and maybe show it to a collaborator who doesn't have CCP4 installed. And you can also download the data and the model to CCP4MG to make a figure. So, of course, sometimes some projects require quite a cycle of manual model building with CUT and refinement with RefMac or Buster. And I've tried different tasks and finally getting to fairly good R factor. So I would like to illustrate CUT from the remote. So okay, this model needs to be improved. So I can run the CUT task and the data, so the electron density, as well as the model are downloaded on CUT. And in this case, I prepared where the ligand was. So you can see on the side, the mole probability window to-do list, where you can click on each entry to find what's wrong with a given amino acids. And here is the fun of placing a ligand in CUT, where you have the green density. And as soon as you start to get it right, you will see it will fit fairly well. So you can then merge your ligand with your model. Remember to save the coordinates and do not change the file name or the folder. And then you can exit and refine, and right away your model is uploaded to the CCP4 Cloud and get processed in RefMac. So the validation also is quite important. So as I just said, mole probability is run for every CUT task. As well, you have this task here, prepare data for deposition, and this will run also the PDB-E validation server. It will take a little while, but you will get the type of report very similar to the one you get when you do the actual deposition. Another very nice feature of CCP4 Cloud is sharing. So there is no longer any need of sending PDBs and MTZ around to collaborators. You can actually share with another user of the cloud. And both users can work at the same time on the same project. This is really a useful feature. You would have to click join here on your project tab to join a project that someone may have shared. And in conclusion, so the data are online when you're using the remote mode. So it's really convenient for sharing. It's on the server, so the server can be archived and the data are safe rather than being somewhere else on a given computer or laptop. Also quite useful for teaching. It's much easier to convince an IT cluster to use a web interface rather than installing very specialized software in their cluster. I really like the tree view. I think it really simplifies writing. I've been asked this year to process data from 2008. I knew what was done, but of course I had to redo it because I couldn't get the proper path. The default settings works really well in CCP4 Cloud. Most of the time, I just open a task and click run. The roadmap, help, and documentation are great as well, so don't hesitate to click on those buttons. My wishes, rather than saying future work for the team, more tasks, more tasks, more tasks. So they are coming, for example, anomalous map, but also being able to run Ampoule or Archimboldo and Simbad on a server is quite useful because those tasks may be very demanding. And I would really like to have private here as well. For the user, it would be really useful to clone a branch. So you may always use the same sequence of tasks, and just cloning them would be really useful to make a user pipeline. Having the ability to email the user when a task, long task is finished would be really good as well. And I could have probably many more ideas. I would like to acknowledge and thanks a lot Eugene Christinel and Andrei Lebedev who developed CCP4 Cloud. I think since March when Eugene helped me install the CCP4 Cloud in Newcastle, we exchanged dozens of emails. And of course, I would like to thank as well the CCP4 core team and the CCP4 developers and friends. And that's me done. Thank you.
Thank you, Arnauld.